So one of the most challenging parts of Unit 3, and I just in real life in statistics, is figuring out what type of test we should run based on the context. And it's even more complicated in real life because there's a lot of different factors. But a lot of students struggle with that for exam 3. And some of the questions will tell you and others will not, and you have to identify it. So I want to go over all the tests and what you're looking for in each type of scenario. So I'm going to just talk about hypothesis tests, but the confidence intervals follow along the same way. So if I'm talking about a one sample t-test, then that would be the same thing as doing the confidence interval for a one sample test, t-test. And same thing for all the other types. So we in this class talked about means or averages and proportions for most of chapter 9, 10, and 11. And then in chapter 12, you talked about two other tests, which are based on categorical data. So we're generally not looking at numbers, but instead we're looking at categories. And so those should stand out a little bit more, but sometimes figuring out the difference between a chi-squared test of independence or a chi-squared goodness of fit is challenging. So we want to, anytime we're talking about averages, right, or means, or in the situation, you would use an average or mean when you're dealing with statistics on that data, such as test scores. Like they might not say the average, but anytime you're dealing with test scores, when we compare test scores, we always are finding the average. So anytime averages means, you're automatically talking about a t-test. Okay, that is used for averages and means. And then from there, what you have to figure out is what type of t-test, because we have 3. We have a one sample t-test, a two sample t-test, and a paired t-test. So a one sample t-test always involves one mean or average. So you have one group, you're taking a sample of one group, and you're comparing that average or mean to the existing average or mean, or the believed average or mean for that set of data. So again, it has one sample. Now, the other two t-tests, two sample and paired t-tests, both have either two sets of data from two different samples or two sets of data on the same set of sample. But you're always comparing like two averages or two means between two different groups. And again, the two sets of data could be on the same group of people, so it'd be the same sample, but again, you're collecting two sets of data on that group of people. So a lot of students mess up the two sample t-test versus the paired t-test. So for a two sample t-test, you're comparing the means or averages for two independent groups. So you're going to have two different samples of different groups of people, and there's no relationship between those people. And often for a two sample t-test, the sample size for each group is different. It doesn't have to be, but most of the time the sample size is different. Now for a paired t-test, you're also comparing the average of means, but now you're comparing it for two dependent groups. Okay, what that means is you're either collecting two sets of data on the same group of people, like heart rate before and after exercise, or weight before and after a diet, things like that, or you're collecting data on a sample of two groups that have a relationship, husband and wife, father and son, mother, daughter, like something like that, that these people have some type of relationship. They work in the same office. Sometimes they do it with cities and they're comparing the temperature twice in the same city. Okay, so again, there has to be a relationship between the two groups. And for the paired t-test, the sample size for both groups is always equal. Because again, you're putting your data in L1 and L2, and then you're finding the difference. So it always has to be the same sample size for the two groups. Now, again, for a paired t-test, again, you're using the t-test command or the t-interval command on your calculator if you're doing a confidence interval. So make sure when you're explaining one sample t-test or paired t-test, you don't just say t-test, you have to either say paired or one sample, because these are both the same calculator command. And so I won't know which test you're referring to. So those are all the ones about averages or means. The second type that we did had to do with proportions. And so for proportion, they're either going to tell you a percentage for a group, a percentage of people that are selecting a certain category, or they're going to say like how many out of the total fit this category. So 12 out of the 30 people are taking statistics. That's a proportion, right? Because then you could do 12 divided by 30 to get the percentage of people that are taking statistics. So when, again, you're talking about proportion, you're talking about a percentage about a group, like that they selected a certain category or part of a certain category, or they're going to say like how many people out of the total, again, are selecting a certain item or fit a certain category. And so for a one prop z-test, we're looking at one proportion. So again, we only have one group, and we're taking a sample from that one group, and that would be a one prop z-test or a one prop z interval if you're calculating a confidence interval on it. If you have two groups, and again, we only have two proportion tests, so they're always independent groups. If you're comparing proportions between two independent groups, it's a two prop z-test. So again, they're going to give you two percentages, or they're going to give you information about two different populations, and you're comparing that information, and that would be a two prop z-test. Okay. Just one thing to be careful about is not every percentage problem is a one prop z-test or two prop z-test. Averages can be percentages. So if they're comparing like the average test score and it's in a percent, that's still going to be like some type of t-test. So just pay attention to if they're talking about averages. Don't just assume, okay, percentage is definitely a proportion. Most of the time it is, but occasionally averages can be presented in percentages. Okay, and then the last two tests are the ones for categorical data. So a chi-squared test is anytime, or test for independence, is anytime we're testing for a relationship or association between two categorical variables. So we're seeing, is there a relationship or association between them? Make sure that you say test for independence. Don't just say chi-squared test. There are multiple chi-squared tests, and so you can't just say chi-squared. You need to say the test for independence. Now, the chi-squared GeoFit test is testing if the model is consistent with the expected model. Often they will ask you something if the model is uniform, which means all the percentages are equal, or gives you the expected percentages for each category. And so you're comparing it to like an expected standard for when you're doing the goodness of fit test. Okay, so we're going to look at a few situations, and you are going to be asked to name the test. And this will also happen on exam 3. So example 4, name the test, part A, says data is gathered from 20 inmates to measure the effects of sensory deprivation. Alpha brainwave frequencies were measured after 7 days in solitary confinement, and again after 7 days in their own cell. So I am sampling one group of people, 20 inmates, but I'm taking measurements on them twice. I'm taking measurements on their sensory deprivation 7 days in solitary confinement and 7 days in their own cell. So I'm taking 2 samples, which means it has to be one of the 2 sample tests. So a paired t-test, a 2 sample t-test, or 2 prop z-test. Okay. Now they don't specifically say anything in this case about averages or proportions, but what you do notice is they're collecting data on the same 20 inmates. And anytime you're collecting 2 sets of data on the same set of people, that is automatically a paired t-test. And so they will be comparing the averages that they get from these alpha brainwave frequencies. But how we know it's a paired t-test is because they're taking 2 sets of data on the same group of people. And that automatically means it has to be, they're dependent groups. And it has to be, the only one we've done on dependent groups is the paired t-test. Okay, so B says 20 freshmen and 20 sophomores students in class take a midterm. We compare their scores. So again, anytime with tests, we are always looking at averages. And so if we're comparing averages between 2 different groups, okay, sophomore and that means it's a 2 sample t-test because they're 2 independent groups. So yes, they're the same sample size, but the freshmen are not the same as the sophomores, and there's no relationship between their groups, so they're independent. Okay, C says, survey Canadians and Americans. We want to find the difference in the percent of foreign-born citizens. Okay? So I am going to compare the percentage of foreign-born citizens in Canada and America. And so I'm comparing proportions in this case. And so I'm comparing 2 proportions, which means it's a 2 prop z test. D says some insomnia patients are given a drug and others are given a placebo. Which subjects sleep more hours? Okay. So I am, again, doing 2 sets of groups. One group is given a drug, another group is given a placebo. And they don't say anything about the relationship between these. So it's not going to be a paired t-test. So it's in independent groups. When we're talking about sleeping more hours, if you think about how would I compare that, I would be comparing the average number of hours slept between the 2 groups. And so I'd be comparing means. And so this is a 2 sample t-test. Because I have 2 groups, they're independent, and I would compare the average sleep they would get. So again, sometimes they're not like as clear. You will need to ask yourself some questions like, are these groups independent or dependent? Would we use proportions to compare this data, or would we use percentages, or would we use averages to compare this data? Okay, the last one, the average high temperatures in January and July are collected for several European cities. We want to find the mean difference between winter and summer in Europe. Okay, so they do tell mean, which means it's a t-test. We are taking 2 samples, one in January and one in July. So we have 2 sets of data, which means it's either a paired t-test or a 2 sample t-test. And because it's on the same cities, we picked Paris and we compared the temperature in January and July. This is a paired t-test. So those are some examples, and I'll do a few more in another video.